Welcome, Hornets. Today I'm going to be discussing limits, specifically one-sided limits. Now, when we're talking about one-sided limits, we can approach from either the left or the right. It is important to remember that a limit is a y value. Let's just write that down. A limit is a y value. Now, when we're dealing with finding limits, what you want to do is recognize that we can do it algebraically, graphically, or numerically. Three different ways. Numerically means we have to make a table of values. Algebraically means that we're working with our algebra skills, and graphically means that we're looking at it from a visual perspective. Now, obviously, the easiest is the visual, so let's just make sure we get our notation. The limit as x approaches a value with a minus behind it is approaching the f of x value from the left. Approaching from the left. This is because the negative is behind the value. So if I'm approaching a value and behind that value I see a negative, it means that the negative numbers are behind me as I am approaching from the left to the right. If I see the limit as x approaches a value from the positive side, this is saying approaching from the right. And therefore, all of our positive values, or the majority of them, are going to be behind us as we move toward our value. So be aware, for one-sided limits, we either have a minus or a plus behind the value, and this tells us the direction of approach. How are we approaching our value? Let's take a look at a graph, please. When we're taking a look at a graph and trying to do a right or left-sided limit, let's just take two lines. One will have a positive slope and one will have a negative slope. We're going to say that this y value is a 4, this y value is a 1, and we're going to be approaching 3. Notice that this is referred to would be a piecewise function having two different parts. So we're looking at the limit as x approaches 3 from the left for this function is the y value associated with the point that is the open circle, 3, 4. Notice the limit is the y value associated with that point, even though the point is not filled in. It's our journey. It's what we're getting closer to, not what we actually reach. For the limit from the right side of this function, we're moving along the y-axis toward this point, and we're looking at 3, 1. So my limit from the left is 4, and my limit from the right is 1. Now, there are going to be times when there won't be anything there. For example, I could approach an asymptote from the left or the right. Let's take a look at this graph. Once again, let's go ahead and approach x equals 3. On this side, I'm going to use a parabola, and the parabola is going to intersect this asymptote at 3, 2. And on the other side, I have the curve, and the curve is just going to go toward infinity. So in this situation, if I'm looking for the limit as x approaches 3 from the left for this function, my answer is the 2. But if I am approaching the limit as x approaches 3 from the right, I'm going to have positive infinity because it will never stop. It's going to approach infinitely as it gets closer and closer and closer to that asymptote. So my answer is positive infinity. Notice that we can have different things happening, and it all depends upon the graph that we're looking at. So this is a one-sided limit. Let's just very briefly go back over it again. What is the y value that I'm approaching when I move from the left to the right? The answer is a 4. I'm moving up along this curve. And the y value that I'm getting closer to is a 4. As I move right to left, I am approaching this way. And as I get closer and closer to that point, I'm getting closer and closer to the y value of 1. So my limit is 1. Our notation that we are watching out for is approaching from the left towards the right when there is a minus behind the value, and from the left to the right, from the right toward the left when we have a positive behind our value. Thank you very much. Have a good day.